Hello friends, today we are going to discuss the OTN client card signal flow in this current video. So in previous video we have already discussed about the difference between DWDM optical transponder and OTN tributary and line card. For details about the difference between transponder and OTN trib and OTN line card, see the below link in which we have described about difference between these two in details. So in this video we will discuss about the OTN client card signal flow. So this document is explained taking the reference of the Huawei TTX OTN Tributary Card. TTX is the Huawei OTN Tributary Card. This TTX card consists of the following modules which are mentioned below. First one is the client side signal processing, control and communication power supply module. In figure left hand side you can see this is the client side optical module, this is the signal processing module, this is the control and communication module, and this is the power supply module. So we'll discuss in detail about all these modules in next slide. So here one thing I want to say you that all these modules are inside this tributary card and all these modules performs a different function. So module functions, let's discuss the below mentioned module function for the TTX board. Client side optical module, signal processing module. Signal processing module is used for the data encapsulation, framing module, OTN processing module and cross connection module. Means signal processing module inside it contains all these modules: cross connection, OTN processing, SDS SONET encapsulation and 10G LAN. These encapsulation and mapping module is for the different types of data, like this is the for SDS SONET and this is for the Ethernet data. Third one is the control and communication module. Control, communication, CPU and memory. This function is performed by the control and communication module. Fourth one is the power supply module, which is used to supply the power to all of the modules. So client side optical module. This module consists of a client side receiver and the client side transmitter. Here you can see these RX is the receiver and the TX is the transmitter. RX1 to RX10 is for that because there are 10 ports in the TTX OTN Tributary Card. So these are the client side optical module in which there is a client side receiver, client side transmitter. Client side receiver performs the optical to electrical conversion. This is here you are showing optical to electrical conversion of the 10 channels of 10G LAN, 10G WAN, STM62, OC192 optical signals. Means the receivers can receive any types of client signals. It can be LAN signals or STM signals. So client side transmitter. Client side transmitter performs the electrical to optical conversion of the 10 channel of the 10GE LAN, WAN, STM64, OC192 optical signal, which is received from the signal processing module. Reports. This client side optical module reports the performance of the client side optical interfaces and reports the working state of the client side lasers. So all the interfaces, the performance of the all interfaces and the working state of the laser are performed by this client side optical module. So moving into the next, signal processor module. The module consists of the SDS SONET encapsulation module, 10G LAN encapsulation mapping module, OTN processing module and cross connection module. So SDS SONET encapsulation and mapping module encapsulates multiple channels of SDH SONET 10G LAN signals and map the signals into the ODU2, ODU2E payload areas. These modules also perform the reverse process and hence the SDS SONET performance monitoring functions. 10G LAN encapsulation and mapping module encapsulates multiple channels of 10G LAN signals and maps the signals into the ODU2 or ODU2E payload areas. The module also performs the reverse process and has the 10G LAN performance monitoring functions. So these two modules, encapsulation modules, are used to map the client signals into the ODU2 payload areas and also performs the SDH and LAN data performance, monitoring performance. So moving further, OTN processing module. OTN processing module frames the ODU2, ODU2E signals and process overhead in ODU2, ODU2E signals. So after payload mapping, OTN processing module adds some overheads and frames to make the ODU2 payload area to ODU2, ODU2 signals. After that, it is cross connection module. Cross connection module grooms the electrical signals between the TTX and the cross connect board through the backplane. So this cross connection card is used for grooming of electrical signals. Then it is coordinated to the backplane services and then is communicated via the backplane to the line card. From the optical line card we will discuss in next video. So till here, the client-side optical module just received the client services and mapping process is done, OTN processing done, and cross connection module electrical grooming is done to the backplane. And this audio electrical signal is sent to the backplane for further communication with the line card. So we are moving to the control and the communication module. Control operation on the board. These functions are performed by the control and communication module. Control operates on each module of the board according to the CPU instruction. These collect information about alarm, performance events, working state, and voltage detection from each function module on the board. Communication with the system control and communication board. So these control and communication module, communication with both the module, client-side optical module, signal processing module, and in backplane, system control and communication module. Power supply module convert the DC power supplied by the backplane into the power required by each module on the board. So on function for performing the function of different module, each module needs the power, and the power supply performs or provide the power to each module to perform better. So here are the signal flow. The transmit and the receive direction are defined in the signal flow of the TTX board. The transmit direction, it is very important. The transmit direction is defined as the direction from the client side of the TTX to the backplane, and the receive direction is defined as the reverse direction. Transmit direction, the client side optical module receives 10 channels of the optical signals through the RX1 to RX10 interfaces and perform the optical to electrical conversion. After optical to electrical conversion, different types of signals are sent to the corresponding encapsulation and mapping module. Like STM signals are sent to the STM encapsulation module, and the LAN or data interface LAN is sent to the LAN or 10G encapsulation module. So module performs operations such as encapsulation and mapping processing and OTN framing. Then the module sends out the channels of audio to signals to the backplane for grooming. Receive direction, the signal processing module receives the 10 channel of audio to electrical signals from the cross connect board to the backplane. Then this module performs operations such as audio to framing, demapping, and decapsulation processing, and hence get the 10 client services. And then module sends to the 10 channels of 10G LAN, 10G WAN, any types of signals to the client side optical module from the TX. So the client side optical module perform the electrical to optical conversion of the 10 channel of the specified data type electrical signals, and then output 10 channels of the client side optical signals to the TX1 to TX10 port. So these are signal flow of the client or OTN tributary card. So these are the important points we need to remember. Audio K signals are always electrical signal. OTU signals is optical signal. At transmit, physical port of client optical module TX or out, electrical to optical conversion is done. At the receiver, physical port of client optical module RX or in, optical to electrical conversion is done. Electrical to optical and optical to electrical conversion is done in optical module. Optical module can be divided in two types: client side optical module and line side optical module. So in case of transponder module, these two modules inside the same card and there is no cross connector is used. In case of tributary card or line card, these two cards coordinate with the cross connect card by the backplane. After optical to electrical or electrical to optical conversion, the signal is processed in signal processing module for encapsulation, framing, FEC coding, and reverse process. All the process which is for TX is reverse for the RX. Number of audio K electrical signal is combined into one OTU for optical signals. So this is the signal flow diagram of the client side module. In next video we will discuss about the signal flow in the line card and then signal flow in the cross connects card. So line card, tributary card, and cross connect card, these all three cards work together and functions like the optical transponder.